Okay, let's go ahead and get started. First of all, huge thank you to everybody out there for taking some time out of your day to learn a little bit about MR2 and Huawei and the solutions we're putting out in the marketplace today. This particular webinar is about Huawei's ES3000 version 2 product, which is a PCIe product delivering real-world application performance. We have two excellent speakers today. The first is going to be Ron Salazar, who's the general manager at MR2. And then after that, we have Mo Moshrif, who's one of the IT storage solutions specialists at Huawei, understands everything about high performance in servers and the PCIe card. A few pieces of housekeeping before we get started. First of all, if you have questions throughout the webinar, we definitely encourage you to send those our way. The best way to do that is to put them in your Q&A panel or your chat panel and just send those, and we'll take those all at the end of the presentation. So please keep it interactive. And speaking of interactive, we're going to have some polling questions scattered throughout the presentation. So when it comes time for a polling question, we request that you participate in the poll and let us know what you think about the various different questions we ask. And we'll share the results with everybody in attendance so you can see what your peers are thinking. Finally, this webinar is being recorded, and it will be up on the Huawei Enterprise USA website shortly after the completion of the webinar. So if you have some colleagues that missed it, feel free to send them that link or send them to the resources page of the Huawei Enterprise USA website, and we'll be able to have them listen to the webinar. So without further ado, I'd like to introduce our first speaker, which is Ron Salazar, General Manager of MR2 Solutions. Ron, take it away.
Thank you, Mitch. Thanks to everybody for attending and participating in this webinar. I thought I'd just kick off the webinar by a short introduction of who MR2 Solutions is and what we do for the IT community. We believe that the data is the #1 asset of any organization, large or small, and we have built our business centered around protecting that data. And we continue to partner with market leaders out there, such as Huawei, and educating people and the IT professional in what's the latest technology, what's upcoming, and possibly what they can use to improve the performance capacity of their data center. Basically, our common conversation with our customer is always centered around data center components such as storage, backup networking, virtualization, and that's all designed to protect your data. Next slide, please. And basically what we talk about in our design, implementation, and support of the network infrastructure, it's always going to be the value proposition that that you'd find in storage, networking, and backup, server and cloud, and security alike. Huawei offers a very unique value proposition in terms of enhancing your current infrastructure without any interruption within your operation. And I guess Mo will go over that in quite details. But MR2, we've been around since 2001. We're very regional, active in marketing here in Southern California. Our reach is from South San Diego all the way to Santa Barbara. We are teamed up with, I guess, a lot of tier 1 manufacturer. And again, our focus is to educate the IT community out there and help them make the right decision and help them basically empower them in building and designing their data center. Basically in engaging our customers and prospects alike, we'd like to follow a certain guidelines and basically those best practices that we do in engaging our customers is always giving them technology deep dives by providing them demos or webinars such as this, and then making sure that they are that the technology that we're bringing into the table is well understood. We also position ourselves in becoming a trusted advisors to our customers by by sitting down with them, doing a whiteboard sessions with them, doing some discovery discovery meetings with them in terms of what's best for their environment. More than likely, a lot of our engagement with our customers also involves providing them a proof of concept to mitigate any risk on their part. And so basically, there's a lot of emerging technologies that are proven to be successful or effective in the IT community, but sometimes they are gun shy in adopting a lot of those technology. And so we advocate for our customers in making sure that they mitigate any risk by having engaging them in the proof of concept, providing them the solutions even before they commit to purchasing, and again, making sure that there's a good fit, before they commit to any of our recommended solutions. These are the sample customers that we have done business before. They range from state and local government to higher education to healthcare, and to all verticals out there. Our solutions is really very much industry agnostic. Everybody shares the same concern, the same level of problems that in terms of managing their data center, and so our solution sets and our product portfolio penetrates different market segments. And so basically, this is my last slide. Huawei is now our latest addition to our portfolio. We see a lot of value in their product offerings. We particularly see the value of their PCIe card by means of improving the performance of any virtualized environment, and we believe that they add value to our solution set. And with that, I'm going to go ahead and turn it over to Mo. He's going to talk about the different product lines that they carry, and that's it. That's all for my part.
Excellent. Thanks, Ron. Hey, before we turn it over to Mo, we're going to have a quick polling question. So I'd like to go ahead and get everybody to weigh in on this. The first question is, what is the most important feature of a PCIe application accelerator card? And we're trying to find out now, is it more of the high bandwidth that you're interested in? Is it low latency? Do you care most about integrated query and management tools? Is it support for ECC and RAID 5, or is it something else? So we're going to give everybody a chance to vote real quick. Go ahead and weigh in on it, and then we'll share the results with everybody, and we'll move on from there. While you're voting, I just want to reiterate about the Q&A section. We're already getting a couple questions, which we very much appreciate. So please keep the questions coming in the chat window, and we'll go ahead and answer those all at the completion. So just about 5 or 10 more seconds to vote, and then we'll take a look at the results. Okay, well, I think you guys can see that the two leading features that are most important are latency, low latency, and high bandwidth. They're kind of jostling back and forth per position there. Low latency was ahead for quite a while, and high bandwidth just took over. So they're about the two most important things, and I know that'll help Mo as he goes forward. So without further ado, we will go ahead and turn it over to Mo. Mo, take it away.
Oh, thank you, Nick. Thank you, Ron. I really appreciate the audience attending this webinar, taking your lunchtime and listening to us. I just want to reiterate that MR2 is truly a focused partner, and we are really looking forward to our partnership. So I just want to talk about our PCIe SSD solution. So the title of this slide is very clear. SSDs here started as an interrupted technology 5 years ago, but now is a technology that is going to stay here. Samsung and Toshiba, last week they announced that they are coming with a 5 years warranty in their SSD. There's a Korean company there. They are approaching us. They're coming with 8 terabytes and 6 terabyte SSD. So SSD, as before, reaching out with HDD, they always say, well, HDD has a high capacity. Obviously, it didn't have the performance. But now the SSD, the price has dropped. It was dropped to $1 per gig. And of course, we know the performance you indicated on the Q&A, the throughput and low latency is the key thing that PCIe SSD provides. And I will later on show you how our PCIe provides the best throughput and the lowest latency in the market. So we move to the next subject, which is what is SSD storage? So SSD storage started a long time ago. Of course, it was designed by Toshiba. Then it moved to the mainstream back in about 6 or 7 years ago. The first SSD was the SLC format, which was a single level cell. And what that provides you is it provides you the highest write lifetime and as well as the best performance. But what happened is industry evaluated the SLC. They noticed, well, it is not providing the price performance that they require. The performance was there, but the price was very high. Companies such as Facebook, LinkedIn, Microsoft Azure, they came to the big industry players and they said we want something in between. So then MLC was kind of designed. It was a multi-level cell. The lifeline was half of the SLC. It still had a very good performance. Then eMLC evolved around the MLC, which is the enterprise, and has improved the multi-level cell, but keep in mind, every time you increase the multi-level selling, then of course it's going to affect your performance. Then TLC was the latest one, triple-level cell devices, is targeted for consumer products. Then of course with the Samsung coming with the 3D, it's going to also affect this equation of the eMLC and MLC moving forward. So we're going to talk about how long Huawei has been in this business. Huawei, of course, is not new to the PCIe SSD. We started back in 2007 with first generation of PCIe. Of course, it was SLC. Then the capacity, if you notice, it was not that big. We were offering only 128 gig and 256, but we were not alone. All the competition had the same capacity. And if you look at the maximum read drive, it was only around 640 to 300 megabytes per second. Then later on, when you look at what capacity we provide today and what is the maximum read drive, you will be really impressed how the technology has evolved from 2007. 2009, second generation, then again, capacity got improved as well as the read drive. 2011 became the third generation of PCIe. Now from 50 nanometer, we switched to 34 nanometer. Then 2012, we announced our fourth generation. That's the last PCIe of the version 1 that was kind of end of life. And now we're announcing the version 2, which is at the beginning of 2015. So 2015, V2, what it provides you, we basically changed the architecture going from 3 FPGA, which I go through it with you in detail, to 2 FPGA. So basically it is a lower power consumption, but capacity and latency is as well as the version 1. Well, the 75,000 stable read IOPS is phenomenal. This is a very key slide I want to focus why we want to talk about PCIe SSD. To the right, of course, the triangle is a hierarchy of the memory that I'm pretty sure many of you are familiar with. So we go from the all the way to the buffer, to the L2 cache, then we go to the lower section of the cache, then we got the main memory. Then if you look at a PCIe sitting right there after the main memory. But I want to focus to the left of this slide when it talks about the PCIe. Of course, the version was PCIe times 8, that's 8.9, PCIe 2.0. And the reason for PCIe SSD, why it makes sense is the following. CPUs are getting much faster. DIMMs are getting much faster. Many applications, especially today, data analytic, for retail, for finance, they want to bring everything and do an inline data analytic. So that means they want to be really close to the CPU. So the shift in the market with the storage players and the flash players is bring the storage close to CPU. And PCIe fits very well with that equation for two reasons. All the standards of the PCIe are well known. Of course, it was designed by Intel. Intel is a major player, 90% of the market. And all the server companies, they understand the PCIe standard as well. So it makes sense to have your PCIe SSD storage acceleration card to be close to your CPU. And now the capacity has increased. We came up with the version 2 there of 3.2 terabytes. And the performance on the bottom indicates that you have a phenomenal performance that the actual SSD SAS drive will not be able to provide you. And these are the performance that you kind of indicated you would love to have. So let's move to the next topic. This is a use case by use case where PCIe really fits. Okay, if you have, these are the applications, and to the left is the latency that requires for those specific application. Caching the server, Web 2.0, major cloud and web applications, they require the lowest latency. If you are sitting there and doing searching on your web browser, you're not going to sit there more than 20 seconds. You're going to basically change the web if the content is not coming your way. It is very important, specifically for cloud applications, because cloud applications, they have to do two things. Not only provide you low latency, but they also have to guarantee that low latency. So moving towards the PCIe SSD really makes sense for the implementation. Then, of course, if you have a blade server, or if you have a HPC application, that also requires lowest latency, but of course that requires a high throughput. Ron talked about VDI, VDL, and having virtualization. That's the next level that can take advantage of it. And of course, mixed workload that is very familiar with many data centers that you have many different applications running. They can also take advantage of PCIe using the tiering mechanism. So let's move to the next topic. Industry perspective of PCIe SSD is the following. You have ISPs, which they're very well known to use PCIe. Part of it is because their application requires caching. They have lots of databases that can take advantage of the PCIe acceleration engine. And enterprise and finance, of course, finance was the first adopter of the PCIe SSD as well as SSD. Because they had the money, they were able to ditch in the cache for the SSD. And because the application requires so much inline data analytics, PCIe SSD was the only one can really provide them that solution. Then, of course, you can move to SMBs and the media. The media is interesting. We just came from an NAB 2 weeks ago, Media Entertainment Conference, and you'll be surprised so many companies moving to the all-flash arrays, PCIe SSD for doing their editing, dumping the sequential editing or caching of the thumbnails to the PCIe SSD. So let's cover the next topics. Is the time for polling question 2.
Outstanding. Thank you so much, Mo. And this next polling question that we're going to get into is trying to figure out what experience you have in the PCIe market. So the question is, which vendors have you used for application acceleration cards? And you can vote for more than one if you've used more than one. So go ahead and vote, and let's go ahead and share the results with everybody as you do. So go ahead and place a vote out there, and let's watch it happen. We are getting about, half a dozen questions so far coming in, which is very much appreciated. So please keep the questions coming. And if you have any questions about anything, if you're new to this technology area, feel free to ask any question. These guys are experts at it, and they'd love to spend some time explaining anything that you need further explanation around. So let's give it about 5 more seconds. Looks like a pretty even split on this particular question. A lot of people use Infusion.io, Huawei, Micron, LSI, a little bit in the lead, and then other. I know Mo would be very curious to know what those others are, but we'll have to save that for another time. Okay, excellent. Let's go on ahead and press forward, Mo.
Okay, well, I'm glad you talked about the competition. I'm going to provide you some slides that shows you how our price performance beat Fusion.io, Micron, Intel, and others. So I indicated early on that I'm going to talk to you about our architectures. What makes our PCIe the best price performance? If you recall, I told you we have reduced the flash controllers from 3 to 2. So this is the version 1. We had the main motherboard that had the flash controller FTL that, of course, connected times 17 lane. Then we had PCIe or 10 gig SerDes that's component of our controller that provides you that great performance. But what we also have is a daughter board that on a version 1 has 2 controllers as well. By the way, all these 2 controllers are FPGA. It was a reason for FPGA. Part of it is one of our main customers. They wanted to have some tweaking done to the LPA on the memory side, so we chose to go to FPGA. The next version after version 2, we're going to have the ASIC version that provides the lower power and the same performance. So moving to the version 2, we're going to have one motherboard, so we're going to have one flash controller, the main, and we have another one, which would be one of the XCS, of course, with the 10-gig SerDes in place. We still have our high capacitance power loss protection in place, so you will not lose that power protection moving forward. Let's move to the next topic, please. Let's talk about how SSD memory controller basically works. You obviously have the host interface. In our case, for the PCIe, it's always the PCIe. Then in all flash array or a storage array, you have SAS or SATA that can provide you that interface. But what makes the whole PCIe SSD or SAS SSD or SATA SSD really works is the flash fault system or firmware that is really hard of your controller. So you have word leveling, which is dynamic or static. Now the technology has moved so fast and improved. Many of them are dynamic, including ours. Garbage collection is a key part of the flash fault system. Given the flash is physically written and the cells that we talked about with the EMLC or MLC or SLC, when you finish your writing, some of the cells within those areas are not being written. So you have a whole bunch of cells that are not being used. What garbage collection does, goes and kind of like a sweeper, it sweeps all those cells that have not been used and kind of collects them, cleans them, and makes them in one array to be able to write again. So this is a key part of the flash fault system. Bad block management is another key. And of course, the biggest one, ECC. We have a very great ECC algorithm in our flash fault system. And of course, you have to have a flash interface to talk to the flash man, which is your media. So high performance double-ended scheduling algorithm. That is something that Huawei has implemented. By the way, Huawei, one of the reasons we come with the best price performance is we design our controllers that I just explained in the last slide, is designed and architected by Huawei with an OEM, so we can have a control over our costs. So traditional way is you write data, then you reclaim data, write data, reclaim data. It's kind of like a sequential. So you basically bring the right data, you have to wait for the reclaimed data. That really kind of slows you down for the write controller. So one of the reasons we had a great write performance as well is because what we do it in a double-ended scheduling algorithm. So it works in parallel. You write the data, then you have the reclaim in parallel with it. So the write data doesn't have to wait for the reclaim data to take place. So it's basically part of our dynamic scheduling on our controller. This is a phenomenal technology. Then another great thing that Huawei has implemented in the architecture and is the patented with our controller is a dynamic RAID algorithm. Keep in mind, these are high-performance cards that are being implemented in a big data base. So you have to have a RAID algorithm in place. You cannot just have a no-RAID flash card. I don't think anybody has card today in a high-end area that doesn't have the RAID implementation. But what we have done, we have provided a RAID algorithm that does it dynamically. It supports the recover data after 16+1, remove the failure flash. If you recall, I talked about how we do the garbage collection. Part of that garbage collection is get rid of the failure flash to rebuild the new RAIDs. So if something, say, during the power loss event we have a capacitance, you didn't complete your write. This failure flash and ECC and the garbage collection is enabled to identify which failure slot was identified. It will collect that rebuilds the rate, and dynamically it will, after the boot up, it will rebuild the rate. It's a phenomenal technology that our competition don't have. So what that provides you, it gives you triple reliability designed to data protection. This is very key thing. I talked about the flash fault system. What are the heart of the flash fault system is dynamic wear leveling, powerful ECC capability, and keep in mind up to 30 bits, which is one sort of error correction. And of course, stream technology. That I will say honestly, many vendors now they have stream technology, but what stands up from Huawei to the competition is a dynamic wear leveling, powerful ECC, and the two functionality I just mentioned, dynamic rate, and as well as the parallel algorithm. This is some specification of V2. I know it's an eye-opener, and probably after the pizza you might want to really dig into it. But just for your reference, what it provides you is the capacity all the way from 600 gig to 3.2. So this is the 3.2 terabyte. The V2 was only up to 2.4. But if you look at it, the performance hasn't degraded. You still offer up to 750,000 IOPS. The main read latency stays still very phenomenal low, 44 microseconds. Maximum write bandwidth is about 2.1 on a 3.2, 1.95, and 1.6 on a higher level, on a 1.7. So these are phenomenal performance. And look at the minimum write latency. That's the one that you kind of replied in your questionnaire, that you want a very low latency. That is related to the write, 11 microseconds. Competition, the Fusion iOS has it around 14. And the rest is the power. The power consumption, I just want to kind of emphasize and make a point that you might say, why your power consumption is too much? The reason is because we use FPGA. The competition uses AC. You have more control over FPGA. But many servers today that they have high power supply up to 650, 750, it would be no issue to distribute up to 50 watts. And by the way, 50 watts if you're doing heavy write, heavy read, non-stop, 24/7. If you're doing 2 or 3 writes per day and say 100 reads, you will never reach the 50 watts. Just FYI. So these are your competition. You indicated on your last questionnaire, these are some of the ones that you consider or you have used. So Fusion IO, of course, it was brought up by SanDisk. They have not introduced anything new. We, on the other hand, has introduced our V2. Our comparison of the performance versus theirs, it stands up by itself, and I have more data to present you from a storage review, third independent party that has tested our PCIe against Fusion IO, against Intel as well as Micron. Of course, as you know, this competition, they are not around anymore. It has been a major shift on the industry. Especially was bought by WD, now it's part of the WD company. OCZ also was bought by, I believe, Hitachi or Seagate, if I'm not mistaken. So they are gone, but we're still up there providing great price performance cards. These are some supported operating system. Of course, the good thing about our PCIe, as soon as you install it on your server, it will come up. It recognizes what operating system you're running. These are the slides from the last V1. I have to upgrade these. Of course, we support all the latest version of the Linux. We have a major collaboration with Red Hat. We also support other operating systems that are very popular, especially Ubuntu is very popular. Of course, VMware for virtualization environments and so. So we support this, and in case any new drivers are available, right away you can download it from the website. So it should be no issue for coming up to speed or bringing up the PCIe SSD as you install the new driver. Time for another polling question.
Well, thanks a lot, Mo. This is our third and final polling question, and this is: what do you think your time frame is for deployment of a PCIe card in your infrastructure? Let us know if you're already using them in production currently, if you'd like to set up a proof of concept, if you think you're more than 6 months out, or even more than 2 years out, or you have no plans whatsoever. So go ahead and place a vote, and let's check out the results. Nobody using one in production yet. Let's see if we get any votes in that category. But other than that, we're getting a pretty good mix of different results. So let's give that a few more minutes. One more plea for questions. If you have any questions about anything that we're covering right now, please enter those in your chat panel, and we'll be able to address those all here in just a few minutes when Mo finishes up the rest of the material. And we'll give you 5 more seconds to vote. All right, sounds good. Continue on, Mo.
Okay, so what was the result? Not that many in production. Is that what the answer was to the last question, Nick?
Yep, that's correct.
Okay, so that's a good news. So I just want to mention that Huawei, we have the best POC program, proof of concept. We'll be glad to work with you to MR2, provide you the card, to test it in your environment to make sure, as you know, everybody's environment is different, the application they're running, the service they're running. So we're very open with the POC of our PCIe card. Let's talk about some of the log volume performance has been achieved with the different OLTP benchmarks. Okay, this is the C benchmarks. As you notice, these are benchmarks with the different cards. Huawei, that was a 2.4. 2.4 provided the best throughput as well as the lowest latency. Then this is your Micron that you have in your questionnaire, your Fusion IO drive. This is the best drive that they have as of today. Yeah. Then you have Verdant that, of course, that was also bought by the Hitachi, nice part of the W. LSI Nitro is not in place. They were bought up by Avago. And, of course, Toshiba. If you look at our number versus Toshiba or versus the Fusion IO, as you see, even Micron has a better number than Fusion IO. So we have the best benchmark on lowest latency. The next slide is Oracle database improvement. So as you see, we have 2 PCIe cards running Oracle ASM. A volume manager is managing this database. And of course, I'd like to mention that we were chosen by Stanford with our PCIe against Intel, Micron, as well as Dell. They chose us, the environment for the Oracle database. They did extensive tests for about 2 months, and they decided our PCIe card provided the best performance for them, as well as the best pricing. So they chose us. It is in production since January now. We're very pleased to provide you that reference. Is a very key reference to have. And that environment was, of course, Oracle. Now, MySQL, we done lots of work with the companies such as Couchbase, which basically is a MySQL, NoSQL, all the new databases that are not your traditional RDBMS. We also have done lots of implementation on SQL shops that they have improved their environment, as this picture depicts. So what you do, what PCIe SSD provides you on a database environment, as you know, you have your indexes, you have your log file, you have your journals. What you do, you put all those journals and log files on your PCIe SSD. You could, of course, put the entire your SQL, if it's not huge, say if it's 2 terabyte, 3 terabyte into the PCIe. But many database administrative people that they know how to tweak and how to tune their database, they choose to put the log file and indexes into the PCIe, and they get phenomenal throughput. Of course, don't mention the low latency, as this picture depicts. So let's look at some third-party testing results. This is from a storage review. Then again, we have Huawei 2.4 terabytes versus Micron versus Fusion IO, Verdant, and LSI Nitro, and the number clearly speaks for itself. Average response time, if you look at it, Huawei 11.7, and 99% of latency 19.84. Micron was the second at 13.09 and 22.45. Fusion IO again third. And it is really important to mention here, when we're talking about these numbers, please keep in mind, you're also talking about performance and price. Fusion IO is the highest price in the market. And we don't know if that's going to change with the SanDisk. I doubt it. SanDisk is not going to change the pricing structure because that's enterprise. So, but our price performance, and I focus a lot on price performance, I don't say just price. We are number one, and our price is 25 to 30% lower than Fusion IO, and of course Micron, and Maryland, and LSI. So this is another reference for you. This is average latency. We talked about it in other slides, but this is also depicting on a NoSQL database. The other one was on an Oracle and MySQL. So it just gives you more perspective that we have tested in different environments. It was not only one database. Now this is third database with MySQL, NoSQL, as well as Oracle, as well as ORTT. It all indicates Huawei has the overall lowest latency against the competition. Now let's talk about read-write latency. This is 4K block, 100% read-write, maximum latency. Then again, you got Huawei 2.4. We also have Huawei in a different server. One was a stock Linux, the other one was HP Linux. We just want to mix the environment, the storage review for more accuracy. They tested, of course, the Micron, Fusion IO, and again FlashMax from on a HP Linux. And you see the chart really explains the max latency. We are still lower, something like 7.8, 14.8, then all the way, let's focus on Fusion IO. You're talking about 13, 17, and 81. And guess what? You're paying 25% more for that. Throughput, that was your first key indicator that switched between latency and throughput. And I'm glad you put that as one of your highest criteria. Then again, we provide the highest throughput in the market today with our PCIe card. The number speaks volume. 747, almost 7,500,000 IOPS per second, and on 1.2 is almost 257,000. Then we go to the Huawei 1.2. If you notice, 1.2 still provides almost the same good IOPS. It's just if you want to go with the lower capacity. Then Micron's Fusion IO and HP lagging third and fourth. So positioning RPCIe, as I indicated in one of the early charts, is for Web 2.0 internet customers, Facebook, LinkedIn, eBay, Amazon. Anybody can take advantage of the lowest latency. Anybody that wants to take advantage of the acceleration needed, such as the databases I indicated. And anybody that wants to really take advantage of the VDI, or you want to do flash cache streaming. Retail is really starting to wake up on PCIe SSD for two reasons. Because of many retail environment that requires inline data analytics. They want to know right away what the customers are buying, what is their habit. They want to send that right away to their marketing and analyze the data. So inline data analytics becoming one of the key things moving forward. So PCIe SSD fits very well with that implementation. So, of course, we have a special offer for this quarter with our PCIe. And of course, this web page that's going to be available to you, I will encourage you to please click on these three links that is indicated in the middle from a storage review. It's 21 pages of extensive study and benchmarking they have done that provides you a great perspective how good our card is. And I also want to thank you very much for your time. Thank you, MR2, for having us as the guest. We're looking forward to our partnership. Looking forward to those of you that do not have the PCIe in your production to give us a chance to see it for yourself in your environment, in your application, that we truly have a great solution. Thank you very much.
Well, thanks, Mo, and thanks, Ron. We do have a number of questions coming up, so I'd like to go ahead and ask those. Mo, this first one's for you, and it's actually a couple of different parts to it, but generally the question is, with the super high performance of SSD, is the PCIe interface itself going to become a bottleneck? And maybe is there any thought about potentially putting the SSD card on a fiber channel interface?
Okay, well, that's a very good question. According to the Flash Summit that we attended 6 months ago, no, PCIe is not going to be a bottleneck because actually there is a major movement is taking place that some vendors are coming up with the PCIe switches. So the PCIe interconnect is getting faster. Keep in mind PCIe 3.0 16 lane is going to provide up to 8 gigabytes per second. And of course on a little bit the lower green side, of course, it's NVMe that Intel is promoting, and we are going to come up with NVMe. So combination of the NVMe, PCIe 3.0, I will say no, the PCIe is not going to be bottleneck. PCIe actually is going to provide you greater performance because of that 8 gig. Keep in mind, a fiber channel, we had a fiber channel hard drive back in 1998 when I was in IBM, and the market didn't really went that route, and the SAS and SATA won. So I don't see any fiber channel back end as an interconnect. Of course, fiber channel is the front end. The SAN connectivity is going to be in place, and it's going to go to the 32 and 64 gig. But on the back end, PCIe, if you recall the picture that I showed you, because it's sitting right there next to the DIMM and next to CPU, it is going to be really a winner. I also want to point out that our newer storage product line we just launched this quarter. What we have done, our controller, dynamic HA controller, they're interconnected to the PCIe interconnect. And what we have done, we can interconnect and scale out up to 8 controllers via PCIe interconnect because of the speed and the performance. So I would say PCIe definitely is here to stay. I hope that answers the
Excellent. Question. It does. The next one is it true that Huawei has an integrated server and storage solution for the HPC market?
Yes, that is absolutely true. Huawei is very dedicated to HPC market. We call that our solution converged and unified technology. Converge on the server side. What converge means is a compute in front, networking on the back. Basically, you don't have the top of the rack switches on top of the server anymore. You have your compute, CPU, GPU in front, connectivity on the back, supports of InfiniBand, supports of 10 gig, supports of 40 gig, and of course from the 4 gig uplink to the 100 gig connectivity as well. And on the storage side, we call it unified storage. That means SAN and NAS now reside on the same controller with the same footprint. So you don't have to go bring another 4 gig NAS head to do the NAS functionality.
Excellent. The next one I'll go ahead and take, Mo, because it is where can I get more information on the Huawei PCIe products and the Huawei portfolio in general. If you look at the URL that's up on the screen right now, HuaweiEnterpriseUSA.com, that is the North American enterprise website for Huawei, and you'll find a great deal of information about Huawei products, about news, and anything else that you're interested in relative to the Huawei enterprise product line, especially here in the U.S. That's a tailored site that's specific with content that's relevant to the U.S. market, so definitely the place you want to look. This next one says, where can I get a live demo of the Huawei application acceleration solution? And I know Mo just mentioned that we recently showed at the NAB show. Next week we're going to be at Interop. So if you go to any of the major trade shows, you'll definitely see Huawei exhibiting there, and that's a great place to see a live demo. You can also set up demos through our partner MR2. They'll be able to work in conjunction with the Huawei team to show demos for anybody that's listening in on this webinar. We can do virtual demos as well, and we have major offices in Cupertino, California, and in Plano, Texas, where we have executive briefing centers where you can see not just the PCIe card, but also any of the Huawei switching portfolio, the servers, and wireless and variety of other products as well. Mo, next question's for you. It says, does the Huawei PCIe application accelerator solution work in competing server brands?
Oh, yeah, absolutely. I'm glad you asked that question. Of course, Huawei has great server product line, but the references that I provided during the presentation, they were the sample was on Dell. We have HP, all the major server providers, Dell, HP, Supermicro, Quanta, PCIe has been tested in all those servers. Keep in mind, the good thing about PCIe, it is a PCIe slot that goes into, and all the servers today, even the commodity Intel motherboards with the support of Intel CPU latest version as well, they all support PCIe standards, and that's the beauty of it. So we do support all the major servers. It has been tested, it has been verified, and we run this smoothly. Just a question regarding the demo. I will strongly suggest work with MR2. We will be glad to do POC with you because it is much better to have a POC in your environment with your application than just me showing you a demo with some numbers. Really, if you want to see numbers and performance, I would suggest you look at the storage review data. Then you will be glad to work with MR2, send you the POC, you test it in your environment, and you'll be so pleased that you say, okay, I'd like to have this in my environment. That would be my suggestion.
Excellent. Just a couple more questions. One is, Mo, this is probably for you. Is there any advantage to using the Huawei servers or application accelerator solutions in environments that already have Huawei switching infrastructure?
Well, the advantage would be, of course, we will love to have a Huawei homogeneity with our servers. Our servers are solid performers. Given the history of Huawei coming from a telco, everything that Huawei builds is a telco built to it. If you look at our server, I hope if you get a chance to come to one of our places that we are today, of course, we're going to be at Interrupt. I'm at Interrupt today. If you look at our finish of our server, design of our server, the SAS backend, the fan architecture, versus the competition, the smoothness, durability, it is so phenomenal that even some competition stopped by in our booth. I remember I was in HPC 6 months ago. Some of the competition, they even praised the Huawei's durability and finish of our server. So yes, of course, we would love you to have our server and with our PCIe if you're running our switches already. That would be great.
Excellent. And the final question, and it's actually come from a number of different people, is asking about pricing. And what we're going to do with that one is turn it over to Ron and really just allow you to connect up with the MR2 team to get quotes and to get more information about pricing. Ron, anything that you want to say about that?
Yeah, sure. Well, our traditional approach is to, because we are very much a relationship-based company, we'd like to, we'd be happy to provide pricing, but we would also would like the opportunity to get to know a little bit about the environment, so we can be your trusted advisor in understanding what it is that you're trying to do. There's so much more that we can offer to the table by way of guiding you in helping you with the design and specification of what you're trying to do. And so by all means, we'll provide you that pricing. Just reach out to us, and we'll give you some ideas as to how much the solution would be. And with that, also not only give you pricing, but also provide you with the best configuration that suits your environment. And again, go forward with that. So I believe everybody has my contact information. If not, we'll be reaching out to you, immediately after this, maybe a couple of days. You should be hearing from my team, Janice, Cliff, or myself, and we'll be doing a lot of follow-up calls. We're trying to put this event together with the hope that we can also use it as an opportunity for us to get to know you a little better. One of two things we can find out at the end of our conversation. One would be a good fit for your environment, in which case we will continue to move forward and continue to find a good solution for your whatever problems that you're trying to solve. or 2, there isn't any good fit, in which case this has just been a good informational session for you, and we would still invite you to our future events as we continue to be an advocate for the IT community out there.
Excellent. Thank you so much, Ron. And Mo, any final comments you want to give to the team?
No, I just want to thank you, everybody that attended this webinar. Please give us a chance, and you'll be very pleased with the performance that this car can provide. So look forward to working with you, with MR2. They're a great team. They're really focused, and I'm really excited about our partnership working with MR2.
Thanks, Mo.
Well, thanks, everyone. Thanks very much to Ron. Thanks to Mo for your great presentation. Hope everybody enjoyed the pizza, and we hope to hear from you again very soon on a future Huawei webinar. Take care, everyone. Good day.